All right, here's our second video in section 3.5 on slopes. We just got done determining a slope. If they gave us a graph, we could find two ordered pairs on the line, and we can figure out what the rise over run is, the change in y's over the change in x's, or our slope, right? Well, what happens if I took the graph away and I just told you what the 2 points were? Could you still figure out what the slope is without a graph? Well, we know that the slope, we're going to call it m now. When we have the difference of the ratio of these two differences is called the slope. We often use the notation m for slope. So we know that the slope is the change in y's over the change in x's, rise over run, right? And so if I give you two ordered pairs, we can figure out the change in y's by subtracting the two y's over the change in x's by subtracting the two x's. That would give us our rise over run. We're going to take our y2, the y of the second point, and subtract the y of the first point over the x of the second point minus the x of the first point, y over x's. Here we go. So I'm going to take away your picture. I'm going to give you 2 points and ask you to determine what the slope is. So now we can't just count rise over run. We've got to actually calculate it. We have our two ordered pairs. This is the x of our first point. This is the y of our first point. This is the x of our second point, and this is our y of our second point. Let's figure out what the slope is of these 2 points by figuring out the rise over run, or the change in y's over the change in x's. When I go to use my slope formula, I have m equals y2, which is 7, minus my y1, which is -2. You notice that I have two negatives now. I have minus a -2, so be careful with that. I've seen in the past that those two negatives really end up making us a positive. Now let's do the change in x's. I have -5, that's my x2, minus my x1, which is -3. Again, those two negatives make us a positive there. 7 plus 2 is 9. -5 plus 3 is -2. So I can say that my slope is 9 over -2. Or we've seen in the past that we can take that negative and move it to the numerator, and it would mean the same thing, -9 over 2. We would actually graph that by going up 9 and left 2, or down 9 and left 2 and right 2. Maybe visualizing it would help. So if I give you a blank graph, and I graph those 2 points, the -3, -2, and -5, 7. You notice that my line has a steep downhill slope. The slope should be negative, right? I can go down 9 and right 2, or I can go up 9 and left 2, would give me the same slope, as long as only one of them is negative. We can't put negatives on both because it would mean something different, right? Why don't you try one? See if you can find the slope between the points -8, 11 and the point -13, 21 without having to graph it. All right, I'm going to find the change in y's. I have my y2 minus y1, so that's 21 minus 11, over my change in x's. That's my -13 minus -8, making sure you do it consistently. All right. On the top, I have a 10. On the bottom, I have a -5. So I can say that my slope is 10 over -5. Or I can reduce, which we always want to, and really say that my slope is -2. Or I can really say -2 over 1, can't I? That means my rise is -2 and my run is 1. What that would mean if I were graphing it is I would go down 2 and right 1, down 2 and right 1. So my line would go downhill. Or I can go up 2 and left 1, up 2 and left 1. My graph is still going to be the same slope, right? Okay. What happens then if our lines are vertical or horizontal? That makes a little bit of a difference. Think about a horizontal line and think about a vertical line, and think about what their slopes might be. Let's look at example 4 before we determine and talk a little bit about horizontal and vertical slopes. If you look at example number 4a, it gives us two ordered pairs, and it asks us to find the slope. I have the point -2, 4 and 5, 4. Let's let's go ahead and use the slope formula like we just did to find the slope between these 2 points. I'm going to find my rise over run. I'm going to find the difference of my y's, 4 minus 4, over the difference of my run, 5 minus a negative 2. Those two negatives make a positive, and I ended up getting 0 over 7. Well, what is 0 divided by 7? Well, 0 divided by 7 is 0. So my slope on this line is 0. What do you think a line looks like if it has a 0 slope? Well, we know what it looks like if it has a positive slope. It goes uphill, right? And we know what it looks like when it has a negative slope. It goes downhill. So what does it look like if the slope is 0? Well, if it has no slope, then it doesn't go up, it doesn't go down. It's a flat road, right? It has no slope to it. It's a horizontal line. So a horizontal line always has a slope of 0. What about this next one? Find the slope of a line that goes through the point -3, 6 and -3, 4. Let's find the slope. Let's do our rise over run. Let's do the difference of our y's. That's my y2 minus y1, 4 minus 6, over my x2 minus x1. That's -3 minus a -3. Those two negatives make a positive, and I ended up getting -2 over 0. Well, what is -2 divided by 0? Well, remember, we can't divide by 0. When 0 is under the line, it's undefined. So we're going to say that we have an undefined slope. We're not going to say no slope because we do have a slope. It's just undefined. But what do you think that looks like then? If positive slope goes up and negative slope goes down and a 0 slope is horizontal, what do you think an undefined slope is? Well, yeah, it's vertical. So think about driving on a horizontal line. It's flat, we can go straight, flat, no uphill, no downhill, 0 slope. But think about what would happen if you tried to drive on a vertical line. Right? The slope is undefined. Again, I know it's kind of silly, but if it helps you kind of visualize what the slopes are, then that may help. A vertical line has an undefined slope. We don't say no slope, we say an undefined slope. And a horizontal line has a 0 slope. It might also be helpful for right now to graph these points. Graph the first 2 points and connect them and see what the line looks like. Graph these 2 ordered pairs, connect them, and see what they look like. I've quickly done that off to the side. You notice that we have a vertical line for part B and a horizontal line for part A. We have a 0 slope and an undefined slope. So recall that a horizontal line has the equation y equals and then a number, right? It touches the y-axis and it has a 0 slope. There is no x. And a vertical line has the equation x equals a number. It touches the x-axis. It never touches the y-axis. Remember, it has an undefined slope.